That is a slot machine program you can write using Python.
Hello everybody, today I'm going to show you how we can write a substitution cipher encryption program. Basically speaking, what we're going to do is that we have a message. To hide the message, we can encrypt it by replacing every instance of one character with another, chosen at random. Using the same key, we can then decrypt the message. When I was at my university, I took an Intro to Cybersecurity course. I turned this program in as a final assignment, and I did get an A on it. I don't know, maybe it'll help you. At the very least, it's a good exercise. Alright, let's get started everybody. We will begin by importing the random module, as well as the string module. Let's create a string of characters named chars. Whatever characters you would like to use for your encryption program, list them here as a string. However, this can be a lot to write. I think a better solution would be to import some constants from the string module. I'm going to include some punctuation. I will import the punctuation constant of the string module. How the heck do you spell punctuation? Okay, that's right. Plus, I will add some digits. String dot digits constant plus string dot ASCII letters. Let's take a look at our characters so far. We have one long string of characters. What if I would like to include a space, a white space? Well, there is a constant for that, but that includes things like carriage return. That's going to warp our results. Let me show you just for a demonstration. String dot white space plus all the other stuff. We have a carriage return and some other characters. I would like to avoid that, so in place of importing the whitespace constant from the string module, I'm going to add a space character. That's good enough. Here are all the characters I will be using this program. Feel free to add more or less. This is all one long string. I'm going to turn the string into a list, where each character is an individual element. To do that, I'm going to take our string of chars, reassign it, then typecast my string of characters as a list. Then let's print it again. Print chars. Instead of one long string, we have a list. A list of all the characters we'll need. I am then going to create a key, which we will shuffle eventually. Key. Then to create a copy of a list, you can type the original list dot copy method. Then I will print my key. I'm going to place these lists within an F string. Chars then key. Let's see what we have. We have two identical lists, one for the original characters and the other for the key. We're going to shuffle this key. Random.shuffle, pass in our list of key. Look at that, all of the characters are now shuffled in a random order. What we'll be doing when somebody types in some text to be encrypted, we will replace every instance of one character within that string, let's say an O, then replace it with another one. Every time we run this program, this key will be reshuffled. Let's ask for some user input. This part of our program, we will do some encryption. Plain text is the original message. Plain text equals, we will accept some user input, enter a message to encrypt. Ciphertext is the name of the encrypted message. That will be an empty string. Okay, let's say a user types in a message. Enter a message to encrypt. I like pizza. It's a very important message. Every instance of a character within my plain text, I will refer to the key and replace that letter with a different one. For example, any Z's, I have two Z's in this program, will be replaced with, let's see, capital B. Every time we run this program, though, it's going to shuffle the key, so it's not going to be consistent. What we're going to be doing is iterating over every letter in our plain text. For every letter in plain text. Strings are iterable. Find the index of every letter from our plain text within our list of characters. Let's assign a variable index. Index equals, take our list of chars, use the index method. We are looking for that letter, whatever letter we're currently on. Then return an index. Then refer to our key, get whatever letter is at that same index. So we will append that to our ciphertext. It's currently an empty string. Ciphertext plus equals our key at the given index. Our ciphertext should be the encrypted message now. Let's print it out. Print, I'll use an F string. Original message. Let's print our plain text. Then our encrypted message. Print our ciphertext string. Let's take a look so far. Enter a message to encrypt. I like pizza. Then here's the new encrypted message. Every instance of a character within my plain text was replaced with another. So for example, any Z's were replaced with E. I have two E's within this encrypted message. If I were to run this program again, it would likely be different. I like pizza. And here's my new encrypted message. My Z's were replaced with semicolons this time. For every letter in our plain text, get the index of each letter, then refer to the key, add the new character to our encrypted message. It's probably best for us not to display the characters and the key, so let's hide those. We will be reusing this key for decryption. Now to decrypt the message, let's copy this section of code, paste it. We are now decrypting. We will ask for some ciphertext, then reset our plain text. For every letter in our ciphertext, refer to our key, append a character to our plain text within our list chars at a given index. We will display our encrypted message, followed by the original message. Let's try it one last time. Enter a message to encrypt. I like tacos. Here's my original message, then the encrypted message. If I were to decrypt the encrypted message, it should give me my original message. I will type in these characters exactly. Hit enter. And here is my message decrypted. I like tacos. All right, everybody, so that is a substitution cipher encryption program for beginners. When I was at university, I did turn this program in for a final assignment for a cybersecurity class, and I did get an A on it, so maybe it'll help you. And well, yeah, that's an encryption program for beginners in Python. What's up, everybody? So in today's video, we're going to create a game of Hangman using Python. I thought that this would be a good mini project for us. While learning to code, it is important to create small projects as you go along. Here's one that we can make together. When creating a project, I like to declare the various variables and data structures I'll need first, followed by the functions I'll need. For this game, we will need a set of words. One of these words is going to be chosen at random. So let's create a few words. I'll add some fruit. Apple, orange, banana, coconut, and one more. Pineapple. Using the random module, let's import that. Import random. Using the random module, we will pick one of these words at random. We won't be able to see what it is, but we can guess what the word is, one letter at a time. Once we reach 6 incorrect guesses, we lose the game. Before each guess, we will display some ASCII art, which I will name as Hangman art. This will be a dictionary,
a dictionary where each key value pair contains a tuple. So this is a dictionary of, we'll have a key, which will be a number, and a tuple. The key is going to represent the incorrect number of guesses. So we'll start at 0. We will display a tuple, which will contain some ASCII art. Then let me just copy this. For one incorrect guess, we'll display some different ASCII art. I'll just put each on a new line for readability. So we're going to go all the way up to 6. Once we hit 6 incorrect guesses, we lose the game. Each key corresponds to the number of incorrect guesses. Once we reach 6, we lose the game. Each tuple that corresponds to the incorrect number of guesses, we will display a certain image. If you would like, feel free to look in the description of this video if you would like to copy this to save you some time. Each tuple will consist of 3 rows, 3 strings. For no incorrect guesses, where incorrect guesses is 0, what's up, everybody? So in today's video, we're going to create a game of Hangman using Python. I thought that this would be a good
encryption program. Basically speaking, what we're going to do is that we have a message. To hide the message, we can encrypt it by replacing
what I like to let's double reach display art. We'll display some different ASCII art. I'll just put each on a new line for readability. So we're going to go all the way up to 6. Once we hit 6 incorrect guesses, we lose the game. Each key corresponds to the number of incorrect guesses. Once we reach 6, we lose the game. Each tuple that corresponds to the incorrect number of guesses, we will display guesses. For 2 incorrect guesses, we will display their head and the main torso of their body, which will represent with a vertical bar. Let me copy this one. For 3 incorrect guesses, we will display their left arm, represented with the forward slash. With 4 incorrect guesses, we will display their right arm. However, if you use a backslash, that's an escape sequence within a string. You have to use double backslashes to literally print a backslash. So with 5 incorrect guesses, we will display their left leg of the person. Then once we reach 6 incorrect guesses, we display the full person. That's when we lose the game, when we see the entire person. That's some ASCII art that we can use. So let's test it just to be sure that everything is working fine. I will print my hangman art at the key of 0 to represent no incorrect guesses. Okay, so when we display this person, we're going to have to use some sort of loop. For every, let's say, line in hangman art at index of 0 for 0 incorrect guesses, I will print each line. With no incorrect guesses, we don't display anything. That's correct. We can't see the person, and that's okay. With no incorrect guesses, we don't display anything. That's correct. We can't see the person, and that's okay. So with one incorrect guess, display the dictionary where the key is 1. That displays the person's head. 2 would be the main torso of their body. 3, their left arm. Their left, we see the entire person, we lose the game. So we can delete these 2 lines of code, we no longer need them. We know that our dictionary is working. I'm going to zoom out a little bit. Following our dictionary, we'll declare the various functions we'll need throughout this program. We will define a function to display man, our hangman. There will be one parameter, wrong guesses. And then for the time being, I'll write pass. We'll fill in this function later. When we display our man, we need to know the number of incorrect guesses to display the right image. We have a display man function and a display hint function. We will have a string of hint. Then I'll write pass for now. Our hint is going to be a list of underscore characters. For each letter that we guess right, we'll flip one of those underscores to be a letter if that letter is correct. I'll create a function of display answer. Within this function, we will display the correct answer either when we lose the game or win the game. And I will write pass. We will create a function of main to contain the main body of code of our program. Again, I'll write pass for now. I'll add the following if statement. If dunder name is equal to a string of dunder main. If we are running this file directly, I would like to call the main function to start the program. Alright, let me zoom out. This will be the main skeletal structure of our program. Import the random module. We have our set of words. We'll be importing more from a separate file near the end of this video. We have a dictionary where the key is a number to represent the number of incorrect guesses, and a tuple to display some ASCII art. We have 4 functions: display our man, display the hint, display the answer, and the main function to contain the main body of code. Alright, let's work within our main function. Within our main function, we will create a variable of answer. What is the correct answer that we have to guess? I will access the random module, call the method of choice, then pass in our set of words. One of these words will be chosen at random. Let's test that. I will print our answer, just temporarily. We should get a random word. Apple, apple, pineapple, apple. I guess it really likes apple for some reason. There we go, we have orange. We are choosing a word at random. We no longer need this print statement. Looks like everything is working fine. Now we'll display our hint. Our hint is going to be a list of underscore characters. I need the number of underscore characters to equal the number of characters in one of these words that is chosen at random. So I could multiply my list by the length using the length function of my answer. So let's print our hint to see what we're working with. With my selected word, we have how many underscores? 1, 2, 3, 4, 5, 6, 7. Okay, we have a different word. 1, 2, 3, 4, 5. That is probably apple. It has 5 characters. All right, so that's our hint. It's a list of underscore characters. When we guess a letter, if it's correct, we'll fill in one of the underscores with that correct character. We need to keep track of the number of wrong guesses. We'll create a variable of wrong guesses. Set that equal to be 0 when we start the game. We're going to keep track of all of the incorrect guesses that we've made. We will create a set of guessed letters. For an empty set, we'll call the set function. Normally in Python, you can't create an empty set with just a set of parentheses. We have to use the set function. Then I will create a Boolean variable of isRunning. Set that to be true. While our game is running, continue playing. Once we lose or win the game, we will switch this to be false to exit the game. We will keep this as true when we initially run this program. After we declare the variables we'll need within the main function, we'll create a loop, a while loop. While isRunning. We don't need to say while isRunning is equal to true. We don't necessarily need to create that comparison. We can just say while isRunning, while this is true, continue doing some code. So what would we like to do? Let's call the function of displayMan, but we have to pass in the wrong number of guesses. Call our function of displayMan, pass in our variable of wrong guesses. When we begin the game, we would like to display one of these images. Then we will display our hint. Then we'll call the function to display our hint. Pass in our hint. That was the list of underscore characters to represent the answer we have to guess. We will create a variable of guess and accept some user input. We'll prompt the user to enter a letter. Just in case a user types in a character that's uppercase, let's add the lower method to make it lowercase. So let's fill in our displayMan function. There's not a lot to write here. When we call this function, we need to display one of these images based on the wrong number of guesses, one of these keys. Within the displayMan function, we'll create a for loop. For every line in my Hangman Art, this dictionary, at the key of wrong guesses. This will be a number, 0 through 6. Depending on what this number is, I will print each line. Print each line of that tuple. Let's see what we're working with. We'll do a test run. So we are displaying no person. We can't see them. For testing purposes, I'm going to change wrong guesses to be 1. We're displaying their head. 2 displays their body. 3 displays their left arm. 4 is their right arm. 5 their left leg. And 6 is their full body. That's when we lose. Now, you don't necessarily need to do this, but I'll add some text decoration before and after. I'll add just a bunch of asterisks before and after. I think that looks better, but you do you. Let's be sure to set wrong guesses back to 0. After we display our hangman, we have to display the hint. What's the clue we're trying to solve? So we will call our display hint function and pass in our list of hint. So within the display hint function, let me zoom out, I will print the following. Between each character within our hint, each underscore, we will display a space character. Strings have a built-in join method. We'll call that, then pass in our hint. For each character within our hint, join it by an empty space. So now when we do a test run, we are displaying an underscore to represent each character. Each is separated with a space. While we're here, we'll fill in the display answer function. We just have to copy this line of code from display hint, replace hint with answer. And that's all we need for the display answer function. So let me test that real quick. After displaying our hint, temporarily, I will display our answer, just to be sure that it's working. Yep, there's our hint, and there's our answer that we have to guess. Okay, let's delete this line of code. We don't want to display the answer. I was just testing it. So the user is going to be able to type in a letter to guess, such as A, for example. Once we guess a letter, if that letter is found within the hint, if it's one of these characters, we need to switch that underscore to be one of those characters. So we'll write the following if statement. If our guess is in our answer. In is a membership operator. If this letter is found within our string of answer, we're going to create a loop. We will create a loop that will iterate once for each character within the answer, but we don't know the length of the answer because Python will choose it at random. So let's say for every index, we can shorten this to I. For I in range, the length of my answer. Let's say the word is apple. The length of the word apple has 5 characters. This would return 5. For I in range 5. Then we will iterate 5 times. We'll iterate this loop once for the number of characters within my answer. We'll check during each iteration if our answer at index of I, during the first iteration, that will be 0. Then the second iteration, it will be 1, then 2, so on and so forth. Strings are iterable. If our answer at index of I is equal to our guess if there's a match, if we guess the correct letter, then we're going to take our hint at that given index of I and set that equal to be our guess. It looks like this if statement is outside of the while loop. I'm just going to indent it by 1, so we're within it. Okay, let's do a test run. I'm going to guess the letter A. Yes, we have one A. Let's do something that's probably not in here. Q. Okay, so there were no matches. We don't end up doing anything. So what is this word probably? This should be the word orange. So let's guess O, R, N, E, G. All right, we know that it works. What if somebody types in some input that's not valid? Before checking if that guess is correct, we'll do some input validation. What if the user types in a whole word, like pizza? we want the user to only guess a single character, not many characters. We'll add the following line. If the length of our guess that we type in does not equal 1, then I will print the following message. Let's say invalid input. Then we will use the keyword of continue to skip this loop. Continue. Okay, enter a letter. I will type the word pizza. We get this message of invalid input. We skip that loop's current iteration. I will guess A. There are 2 A's. I will type banana, and again we get invalid input. We have to guess one letter at a time. What if somebody types in a number, like 1? We would like to prevent that. So within this if statement, I would like to execute this code if our guess is not an alphabetical character. I can add the following. Or not take our guess, dot, use the is alpha method. If our guess is an alphabetical character, this returns true. If it's not an alphabetical character, it's false. So we are checking if this is not an alphabetical character, we execute this code. Let's try this again. I will type in 1, invalid input, 42069. Invalid input. Let's say we guess the letter A. What if we type in a letter we have already guessed? I will guess A again. If they already guessed a letter, I don't want that to count. We'll skip the current loop iteration. I'll add another if statement. If our guess is in our set of guessed letters, then I will print the following. I'll use an F string. Our guess is already guessed. Oh, one thing I'm forgetting. Once we check that our guess is not within our guess characters, we'll take our guess letters. This is a set. Add the guess. We're keeping track of the letters we have already guessed. So I will type, let's guess A. We have 1A. If I were to guess A again, we get that message of A is already guessed. And then be sure to add continue to skip the current loop iteration. All right, now going down to this if statement, if guess is in our answer. If we guess a character that's incorrect, we will take our variable of wrong guesses, increment it by 1. Wrong guesses plus equals 1. Let's do a test run. I will guess A. There is an A. What about Q? There is no Q. We display our dictionary where the key is 1. We display that ASCII art. R? Is there an R? Yes, there is an R. This is probably
Hmm.
Orange are where the wrong guesses plus equal wrong guesses. That's if I were to guess A. For keeping track of the letters we have already guessed. The guess. For keeping track of the letters, we have 1A. If I were to guess A again, we get that message of A is already guessed. And then be sure to add continue to skip the current loop iteration. All right, now going down to this if statement, if guess is in our answer. If we guess a character that's incorrect, we will take our variable of wrong guesses, increment it by 1. Wrong guesses plus equals 1. Let's do a test run. I will guess A. There is an A. What about Q? There is no Q. We display our dictionary where the key is 1. We display that ASCII art. R? Is there an R? Yes, there is an R. This is probably orange. I would like to be sure we display the entire person. I will guess some wrong characters. We know that that works. Now we need a win condition if we guess all of the correct characters and display the entire word. We'll work on that next. If there are no underscore characters, not in our hint. This will be true if there are no underscore characters in our hint. If underscores not in hint. We'll call our function of display man, pass in the wrong number of guesses. Call the function of display answer. Pass in our answer. We will print the text of you win, then set our Boolean variable of is running equal to be false. Let's win this time. I already know that this word is probably pineapple. Let's guess something incorrect. There we go. We have 2 wrong guesses, but we have correctly guessed the word pineapple. You win. And we exit the program. What if we lose? I'll add the following if statement. Else if our variable of wrong guesses is greater than or equal. So the length of our hangman art is a total of 7. There's 7 total keys. But once we hit 6, we lose the game. With this else if statement, if the length of our hangman art, the length of our hangman art is going to be 7. So we are going to subtract 1 for 6, for a total of 6. Once our wrong guesses is greater than or equal to 6, that means we lose the game. We will call the displayMan function, pass in the wrong number of guesses. display what the correct answer should have been, display answer, pass in our answer. We will print you lose, then take our Boolean variable of is running, set that to be false. I'll guess incorrect letters. There, the word was coconut. We have 6 incorrect guesses. We display the entire hangman. The correct answer was coconut. You lose. If you would like to import a larger variety of words, we could create a separate Python file for that. So within our project folder, we will create a new Python file. I will name this Python file words list. This will be a Python file. Let's take our set of words, cut it. I'll add a note that these are words for hangman game. Words will be a set. I recommend looking online for a very large set of words that we can use, then just copy and paste them within here. While browsing online, I found an extensive list of animals that I can use. So here are all the possible words for my game. So, from my main Python file, I have to import this module of words list. From the module of words list, import words. And now I have a greater variety of words I can use. Let's run this one last time. This word has 4 letters. I'll guess the vowels. There's an A, no E, I, O. There is an O. Is it goat? Nope. T, R, boar. All right, the word was boar. You win. All right, everybody, so that is a game of Hangman that we can create using Python. Hey everybody, so we have